Hey guys, Mr. Backerberg here. In this video, we're going to look at lines that are tangent to a curve. So a tangent line is a line that just barely touches a graph at one point along the curve. So for example, if we were talking about the graph of a parabola, a tangent line would just barely touch the parabola at one point on its curve. So in this example, we are going to look at finding the slope and also finding a tangent line for the parabola y equals x squared. And we're going to look specifically at the point 2, 4. So we're going to try to find the slope of the parabola at this 2, 4 point, and then write an equation for the tangent line that just barely touches our parabola at this 2, 4 point. So we've got just a normal y equals x squared parabola centered at the origin, and we're focusing on the point 2, 4. So I'm just going to approximate that right now. In order to find slope, though, we need another point. And so what we want to do is find a point that's arbitrarily close to this 2, 4 point without actually landing on the exact same point. But we want it to be really, really close. So we're going to look at some other point in here that's super close to this 2, 4 point. And what we're going to do is introduce this h value. And what h stands for is it's the distance away from this number 2. So we've got the point 2, 4, but we're going to go a little bit further, just a tiny bit further past that 2, 4 point by adding this h value to the 2. So we're creating another point. We're at the 2, but we went just this little h value extra. Now, as far as the y value for this point, we would need to take this 2 plus hx value and plug that into the equation. So what we're going to end up with is just 2 plus h squared, since our equation is x squared. So if this is our x value, then the y value is just that number squared. Now, what we can do with this is we can use our 2, 4 point and this new point that we just came up with by using that h value, and we can try to find the slope there. So if I take the second y value, that's going to be that 2 plus h squared minus the first y value, which is just 4. On the bottom, I want to take that second x value, so 2 plus h, and I'm going to subtract the first x value, which is just 2. Now I'm going to start on the denominator because there's some simplifying that's going to happen down there. I see this positive 2 at the beginning, and I see this minus 2 on the back end. So those end up canceling each other out, leaving us with just h in the denominator. Now there is some simplifying that needs to happen in the numerator, and specifically we're going to start with that 2 plus h squared. Squaring that means that we're multiplying it by another 2 plus h. So if we were to FOIL this out, 2 times 2 is 4, 2 times h is 2h, h times 2 is another 2h, and then h times h is h squared. So we have all that, but then we still have this minus 4 on the back end of the numerator. And what I notice is happening there is that we have this positive 4 in the front and this negative 4 on the end. So those are going to cancel each other out. We can combine these like terms, these two h's. So we have 4h plus h squared all over h. And now there's a little bit more simplifying that can happen. I can actually take a GCF of h out of the numerator. So then we have 4 plus h, and this is all over h. And then I'm going to be able to cancel out this GCF of h that we just took out of there with the h that was on the bottom. So that leaves us with 4 plus h as we simplify all of that down. Now what we're going to do with this, we said that h was the x distance that we were away from that 2. And in order to come up with our tangent line, we wanted that distance to be super close to that 2 that we started with. So what we're going to do with this is take the limit of this as h is approaching 0. So as the distance between our 2 points shrinks closer and closer together until it's almost a 0 distance away. So if I do the limit of 4 plus h as h is approaching 0, I can direct substitute 0 in there, and then I would get 4 plus 0, so it's just 4. So the slope of this tangent line for our parabola at the point 2, 4, the slope is just 4. So that's the first part of our answer, finding the slope of the tangent line. But now we actually want to write out an equation for the tangent line at this 2, 4 point. Well, we've got a slope to deal with, and we've got a point to deal with, so I'm going to use point-slope form. And point-slope form, remember, is y minus y1 equals m times x minus x1. Our x1 and y1 come from the point that we're given, so I'm going to go y minus 4 equals, we know that our slope is 4, and then inside of my parentheses I've got x minus 2. Now I'm going to simplify this down to get it in slope-intercept form. So I'm going to distribute the 4 on the right-hand side. So I get y minus 4 is equal to 4x minus 8. I'm going to add this 4 over to the right-hand side. So I get the equation y equals 4x minus 4 as that equation for this tangent line. Now what I'm going to do with that is I'm going to graph both of these out. I'm going to graph out just that x squared. I'm going to graph out this 4x minus 4 to kind of prove that we do in fact have a tangent line happening at this point 2, 4. So in my calculator, I have both of those typed in. I have the x squared and I have the 4x minus 4. I'm going to do zoom 6 to get my nice 10 by 10 window. So we can see our blue parabola and then we can see our red line. I'm focusing on this 2, 4 point, so I'm going to zoom in a little bit. So I'm going to hit zoom 2, and I want to go over until I get to that x value of 2, and then I want to go up to my graph at that y value of 4, and I'm just kind of investigating what's happening in here. We said that a tangent line should just barely touch our graph at 1 point. So as we zoom in further on this, it looks like our lines are kind of overlapping, but there is just that tiny little intersection point happening right at that 2, 4 point. So in general, if you're trying to find the tangent to a curve y equals f of x at a specific point, so to find that slope, we're going to take the limit of f of x plus h minus f of x all over h, and we're going to do that limit as h is approaching 0. And remember, h represents the distance between your 2 points. So because we're doing that limit as h is approaching 0, what you're saying in there is that you're bringing your 2 points infinitely closer together until the distance between them is almost 0, and that will help you approximate the slope of that tangent line, as long as that limit exists. Now that expression, f of x plus h minus f of x all over h, that's called the difference quotient of your function f. So in this example, we're going to look at the function 1 over x, and we want to find the slope of the tangent line at the x value of a. So we're going to use what we just talked about. It's going to be f of x plus h minus f of x all over h. And the x value specifically that we're talking about is this a value. So I can actually rewrite this a little bit to say f of a plus h minus f of a all over h. So if I think of f of a plus h, that means that I have to take a plus h and plug it into my function where the x value is. So this is going to say 1 over a plus h minus f of a would just say plug in a, so that would be 1 over a, and then this whole thing is supposed to be over that h value. Now there is a little bit of cleanup work that we can do in here to try to simplify this down. I'm going to take that denominator of h right now, and I'm going to rewrite it as 1 over h times 1 over a plus h minus 1 over a. And what I want to do in there, because we're subtracting fractions, I want to try to get a common denominator. So what I'm going to do in this first fraction is multiply top and bottom by just a, but then in the second fraction, I'm going to multiply top and bottom by a plus h, and that'll give us a common denominator in there, so we're going to be able to put these fractions together. So we've got 1 over h times, this first fraction turns into a over a times a plus h, and we're subtracting, this is going to be a plus h all over a times a plus h. Now we've got common denominators, so we can go ahead and put these together. So we're going to end up with 1 over h times a minus a plus h all over a times a plus h. And if we look at distributing that negative in, that's going to turn this a into a negative a, and it's going to turn that h into a negative h. So then what we can do is we can combine this a with this negative a, and those are going to cancel each other out. So now we've got 1 over h times negative h over a times a plus h. And then because of this h on the bottom in the front and this h on the top of this fraction, those are going to cancel each other out, leaving me with just negative 1 in the numerator. So we get negative 1 over a times a plus h. Now we're not quite done here because we still need to do our limit with this. So we're supposed to do the limit as h is approaching 0 of this fraction that we just came up with, negative 1 over a times a plus h. So if I direct substitute this 0 in here for the h, the denominator really just turns into a times a, so we get negative 1 over a squared as the slope of this tangent line at some general a value. Now in the second example, we're looking at that exact same function, 1 over x, but we want to find the slope at x equals 2. And we just did 95% of the work in the previous example. We just figured out that that slope at any general point was going to be 1 over a squared. And that a value is just some specific x value that we're dealing with. So if we want to find the slope at an x value of 2, I'm just going to plug 2 in here. So we get 1 over 2 squared. So the slope at an x value of 2 ends up being 1/4. That's going to be it for this video. Thanks for watching.